Welcome to this session on normalization in DBMS. Normalization is a technique used to design efficient and consistent databases by organizing data in a way that reduces redundancy and improves integrity. It plays a crucial role in ensuring that your database remains scalable, easy to maintain, and free from anomalies. What is normalization? Normalization is the process of organizing data in a database so that it meets certain rules or normal forms. It removes redundancy and ensures dependencies are logical. The idea is to split large, complex tables into simpler, related tables that are easier to manage and update without causing issues. Objectives of normalization. The key objectives of normalization are minimize data redundancy, no necessary duplication of data. 2. Eliminate, update, insert, and delete anomalies. 3. Ensure logical data dependencies. These goals make the database more efficient and maintainable. Why is normalization needed? Without normalization, databases can suffer from several problems. Insertion anomaly. Can't add data due to missing other fields. Deletion anomaly. Removing one record deletes unintended data. Update anomaly. Redundant data must be updated in many processes. Normalization solves these by organizing data into structured formats. Unnormalized form UNF. UNF is the raw data format where all information is stored in a single table, even if it contains multi-valued or repeated data. For example, a customer table with multiple phone numbers in one field. This structure is prone to anomalies and hard to query. Example of UNF. Consider a table customer in bracket name, comma, order, close the bracket with entries like John in bracket pen, comma, book. This is unnormalized because the orders column has multiple values. It violates the basic rule of atomicity. Each field must hold a single value. First normal form. To bring a table to first normal form, ensure each column contains only atomic values and each record is unique. In our earlier example, we separate each order into its own room. John, comma, pen and John, comma, book. This eliminates repeating groups and satisfies first normal form. Example of first normal form. After applying first normal form, we take the customer bracket name comma orders table customers table and turns it into John comma pen John comma book. Now each cell contains just one value and we have removed multi-valued attributes aligning with the 1NF request. Second normal form. A table is in second normal form if it is in first normal form, and every non-prime attribute is fully functionally dependent on the whole primary key. This means there are no partial dependencies. This is important in tables with composite keys. Every field must depends on the full key. Example of second normal form. Suppose we have a table where student ID and course ID together form a key, but student name depends only on student ID. That's a partial dependency. In second normal form, we move student name to a separate table where student ID is in the only key. Third normal form. To achieve third normal form, a table must be in second normal form and have no transitive dependencies. In other words, non-key attributes must depend only on the primary key, not on other non-key attributes. This prevents one non-key field from indirectly depending on another. Example of third normal form. Take a table. Student in bracket ID comma department ID comma department name. Here department name depends on department ID, not the student ID. So we split the table into two. One for student in bracket ID comma department ID and one for department in bracket department ID comma department name, satisfying third normal form. Boys Code Normal Form BCNF. BCNF is a stronger version of third normal form. It states that every determinant must be candidate key. In simpler terms, no non-trivial function depends should be exist unless the left hand side is a super key. It fixes certain anomalies not covered by third normal form. Fourth normal form. Fourth normal form addresses multi-value dependencies. A record should not contain two or more dependent multi-valued facts. For example, if an employee can have multiple projects and skills, we should separate those into distinct related tables. Fifth normal form. Fifth normal form deals with joint dependencies and ensures that a table cannot be split further without losing information. It is useful in complex databases where maintaining logical consistency after multiple joins is critical. Summary of normal forms. To summarize, first normal form atomic values. Second normal form no partial dependency. Third normal form no transitive dependency. BCNF every determinant is a candidate key. Fourth normal form no multi-value dependency. Fifth normal form no joint dependency. Each level improves database quality and design. Advantages of normalization. Normalization offers many benefits. First one reduces redundancy. Second one enhances data integrity. Third one simplifies maintenance. Fourth one enables easier updates. Fifth, a well organized database is lean, reliable, and efficient in handling complex queries. Disadvantages of normalization. However, normalization is not perfect. It can lead to complex queries with multiple joins, slower read operations, higher CPU usage for large joins. Sometimes a denormalized structure is preferred for performance critical applications like reporting. Real world example. Imagine on e-commerce database customer, orders, products and payments are all in separate tables without normalization. All information might go into one table, making updates messy. Normalizing this design keeps it modular, scalable, and efficient. To normalize the tables. After designing an entity relationship diagram, normalization helps convert it into a relational schema. Each entity becomes a table and relationships are transformed into foreign keys. This step brings high level design with real implementation. Quiz and recap. Let's recap. What is a transitive dependency? Which normal form removes partial dependency? What is a multi-value dependency? These questions help you revise the key points. Normalization is a foundation for anyone working with databases.